let me explain about the photoelectric effect. This problem is based on photoelectric effect. So before proceeding with this problem, I would like to explain about the phenomenon of emission of electrons on irradiation. Irradiation means attack of any radiation or attack of photons. After all, light consists of several photons. So when light is incident on a sheet metal, let me consider a sheet metal like this. So the light falls on it. Okay, so this is photon. And what happens on irradiation on the sheet of metal? The electrons available on the sheet of metal will be kicked out. Okay, so these are called photoelectrons. Photoelectrons. And this effect or this phenomenon of emission of electrons on irradiation on a sheet metal is called photoelectric effect. Okay, so this is one of the Einstein's findings. Photoelectric effect. So what is photoelectric effect? It is the phenomenon of emission of electrons where from the surface of a metal, from the surface of metal, okay, metal, when light is incident, that is light falls on a sheet metal. Okay, so always when you want to explain or when you want to understand the phenomenon of any such that is features, for example in this case photoelectric effect, you can break down all this into small sentences so that you will be able to understand very clearly. So what are the things occurring here during photoelectric effect? The emission of electrons takes place. Where from? From the sheet metal. When light falls on it. That's all. So when you explain as a definition, it is what is photoelectric effect? Based on these terms you can easily explain. It is the phenomenon of emission of photoelectrons from the surface of metal when light falls on that sheet metal. That's all. Okay, so this is called photoelectric effect. Are you able to follow? Right. So in this case we call it H nu, and we cannot expect all the electrons to come out of the surface of the sheet metal. Okay, there are some dull electrons, it should be excited, and that function is called work function, and that amount is H nu 0. Okay, so only after this you are able to get the phenomenon. Okay, so the kinetic energy of this emission, this is the kinetic energy with which the electrons are emitting from the surface of the sheet metal, is equal to, that kinetic energy is equal to, that is H nu minus H nu 0 or naught. Okay, and this H nu naught is called the work function. So that is the energy required to kick out the electron, and that is actually compensated here. So it means what? That is the photon. You can rearrange this equation. This is the photon absorbed, okay, and kinetic energy is partly released, and some amount of energy is used up to excite the electron, and that is called phi naught also, which is nothing but work function. Are you able to understand this one? See, certain amount of photon. This is the photons, energy possessed by the photon. So E is equal to h nu according to Planck's equation. So these light is coming with certain amount of input energy, and some we cannot say that is the entire energy is used up and converted into kinetic energy. No. Some part quantity is used up to excite the electron, and that is called work function. Okay, part quantity. And the remaining quantity is transferred as kinetic energy, because according to law of conservation of energy, we know energy is interconvertible. You cannot generate energy, you cannot destroy the energy. Energies are interconvertible. So when the energy is so in such a way we can prove here the energy is conserved. How? For example, this is the photon, the incident light's energy, and part, as I already told you, the part quantity is used up to excite the electron, and these electrons are ready, and these ready electrons, they are coming out of the surface of the metal, and they are photoelectrons, and they possess kinetic energy. So this kinetic energy is added here. So this is the input, this is the output, and some quantity is used up to excite, to get ready for the emission. So this is called photoelectric chemical equation. Okay, so we can make use of this equation, take down, and this part is the work function. Okay, now let us go through the problem. A photon. What is the wavelength of photon? 4 into 10 power minus 7 meter. That is the wavelength of photon. So you can note down, lambda is given. How much? 4 into 10 power minus 7 meter. And then that strikes on the metal surface. Yes. So this photon strikes on the metal surface, and its lambda is given. So that is the 4 into 10 power minus 7 meter. And then the work function of the metal. So from this one point is very clear. The work function is the property, is the parameter of what? Not the light, but the type of metal, nature of metal. It depends on the crystal lattice. Okay, the crystal lattice, crystal pattern of the sheet metal. If you use different types of metal, you will have different work functions. So that is why it's clearly given, that is work function of the metal. That particular metal is 2.13 electron volt. So what about this one? This energy is 2.13 electron. Okay, got it? Next. And what is asked here? Energy of the photon in electron volt. So first of all, we have to find out the energy. That is energy. H nu is equal to energy, is it not? If lambda is given, how to find out the energy? We know already. E is equal to h nu. But unfortunately it is given as lambda. So nu is equal to C by lambda. So we can substitute and get the answer. Am I right? Right, proceed. So, shall I erase this part? Now let us work out the energy of photon. That is incident photon. So lambda is given for that. How much? 4 into 10 power minus 7. So we want to find out E is equal to h nu. And we know already nu is equal to C by lambda. So E is equal to hc by lambda. So E is equal to, what is the value of h? Planck's constant, 6.626 into 10 power minus 34. And you have to put June second here. June second. And then divided into. Then 3 into 10 power 8, and then here into meter per second, is it not? So 3 into, meter per second, June second, then meter per second. Okay, and then divided by, what is lambda? 4 into 10 power minus 7, and here you can put meter. So second inverse cancel, meter cancel. So you have got joule. Okay. Now 6.626 into 3 divided by 4 into 10 power minus 34, and you have 10 power 8, so plus 8, and then 10 power plus 7, is it not? Am I right? So that is equal to, so this is going to give you joule only. So how much? 3 into 6.26, you can work out the values. Let us use a calculator. 3 into 6.626 divided by 4. So 4.9695. Okay. 4.9695. Is equal to 4.9695, and then into 10 power, this is 15, then 34 means minus 34 plus 15, how much? 9, and then 2, 1, 19, huh? Okay, so into 10 power minus 19 joule, or is it called? And here we have the equivalent, that is, it is asked in electron volt. We already know 1.6020 into 10 power minus 19 joule is equal to 1 electron volt. Okay, so we can convert this. We can divide by this. Is it not so? Energy in electron volt is equal to 4.9695 into 10 power minus 19 divided by, and what about this one? 1.6020 into 10 power minus 19. So this can be cancelled. So 4.965 divided by 4.9695 divided by 1.620. 1.6020 is equal to 3.102, right? So energy is equal to 3.102. How much? Electron volt. Got it? Now we have already the equation. Finished? Shall we do this?
Yes.
Right. So we have H nu, which is nothing but E, which is nothing but how much? 3.102. So electron volt. And what about H nu 0, which is the work function? How much? That is given 2.13. Is it not? Now kinetic energy is equal to H nu minus H nu naught. So that is equal to 3.102 minus 2.13. How much? 2. 10 minus 3, 7. 0. This is not 10 minus 1, 9. So 0.972 electron volt. So this is the kinetic energy. But this kinetic energy of emission is, photoelectron is, that is 0.972. And it is asked as velocity also. We have to find out the velocity. This is kinetic energy. Now we are supposed to find out the velocity. Shall I do this part? So here we have kinetic energy. Half mv squared is equal to 0.972. Because we already know kinetic energy is nothing but half mv square. So from this we know the mass of electron. What is the mass of electron? Refer. Always you must have the flashcard where you should have all these things. So V squared is equal to 0.972 into, and before that you are supposed to convert this, because this is kinetic energy in electron volt. Again you have to convert this into joule. Okay, so first to convert this into joule. This is 0.972 electron volt. Now we have to convert this into joule because this is the mechanical equivalent. Okay, so 0.972 into 1 electron volt is how much? Equivalent 1.602 into 10 power minus 19 joule. So we have to multiply. So 1.602 into 10 power minus 19 joule. Okay, so what is the value now? Zero 0.972 into 1.602 is equal to, that is 1.557, correct? So that is equal to 1.557, 557. That is equal to 1.557 into 10 power minus 19 joule. Now we can comfortably write down the mechanical unit. Kinetic energy in joule. Kinetic energy in electron volt, this one. But they should be given in mechanical unit. So joule. Now actually joule is called mechanical equivalent of heat. So 1 by 1 V squared is equal to 1.557 into 10 power minus 19 joule. Right? And we want to find out V. So 1.557 into 10 power minus 19, right, divided by, and this is reciprocated into 2, and the mass of electron here. Are you will follow? Right. And what is the mass of electron? 9.1. Okay, 9.1 into how much? 10 power minus. So 1.557 into 10 power minus, you can multiply these two. So 2 times, 2 sevens are 14, balance 1, 10, 11, 1, 30, 31, correct? So 3.114 into 10 power minus 19 divided by, what is the mass of electron? 9.11 into 10 power minus 31 kg. So what about this one? This is joule, right? And here divided by kg. Kg means weight, is it not? Joule kg. Joule per kg. But you know the velocity should be available in terms of the unit meter per second. Okay, so take the V, the square root of V. So taking square root of V, you have to take like this. Okay, and you should have always the even number for taking square root. Okay, so you can convert this. So V is equal to how much? The whole square root of, and before that you can (3.114) divided by 9.11 into, and 10 power minus 13 becomes 10 power plus 31. So 31 minus 19, how much? 8. 8 11 minus 9, 2. 12. So 10 power 12. Correct? 10 power 12. Now let us take the square root. Okay. So V is equal to, we can take outside the bracket, outside the square root, that is 10 power 6. Is it not? So the remaining is 3.114 divided by 9.11. Okay, so that is equal to 3.114. Let us divide that one. 3.114 divided by 9.11. Okay, so 0.3418. 0.3418 square root into 10 power 6 meter per second. So here, now taking square root of 0.3418. So it is 0.584. Into 10 power 6 meter per second. So V is equal to 5.84 into 10 power 5 meter per second. Okay? Correct? Now I will teach you how to get this from logarithm also. Get me the logarithm table, because you are not allowed to use calculator during examination. Okay, let me sum up. Can you, Kavya, can you write down some of the answers, please? Come. And you can get the joule also, in terms of joule. Electron volt, also write in joule. Kinetic energy in joule. Joule. And velocity. Okay, right. I'll bring the logarithm table. Any other better book? Yeah. Somebody can go to the board. Let's go. So we are going to work out the logarithm for this portion, okay? Because we have already worked out we have taken the square root outside the value 10th power outside the square root. Now what we are going to do, we are going to work out only this part, okay? Right, we can erase this portion. No, this portion. Write down. Numerator, denominator. First take the numerator. 9 log of 3.114. Okay. And then denominator 9.11. Now here comes, can you give me the value of the logarithmic log of, you please check. Now you had to show it in the camera. Now listen, what is the value? Numerator 3.11. So how to take this 3.11? This is the logarithmic table. Okay, probably it is not so clear. Right, so log 3.1 means 3114. So you have got 31 here, 31, and check in 1 and then in 4. So it means a 4928 plus 6, the mean difference is 6. Write down. So 4934, very good. And then log 91 1. So log 91 is here. I think we should use a better logarithmic table. 91. So blood. And 91, then 1. So 1 means 9595. Okay? So 9595. Now you have to subtract. In logarithm, if it is a quotient, that is division, you have to subtract. Multiplication means add. So that is called the quotient rule and product rule. Okay, this is the quotient rule where we subtract. And this is called the Clss table, where you can find this. This is the science data book. You can find these logarithm and other values. So make use of this effectively. Others can also check simultaneously. We'll check. What happened? Why are you erasing? Now 1 bar, drop 1 bar. 1 bar. Okay. Now here, see, wait a minute. So we are subtracting everything here, but when you take 1 from this, it becomes 1 bar. So 1 bar minus 0, 1 bar. So 1 bar 0.5339. But now listen to me, this is inside the square root. So after subtracting, you are divided, but you have to find out, our objective is to find out the quotient, square root of the quotient. So we have found out the quotient, but we have to find out the square root. So in this case, you have to multiply this by 1 by 2. Okay, because you should not say antilog. Okay, first you have to finish this one, then you can finally take the antilog. So take the log of this one. Let me explain to you. Take the log of 3.114. So he has taken log of 3.114 as 4934. And denominator, that is log of 9.1. So log of 9.11, that is 0.9595. And that is quotient. So he has subtracted. So the value is 1 bar 0.5339. You should not immediately check the antilog. And before that, you had to solve this one. So this can be written as 3.114 divided by 9.11 power 1 by 2. Okay. So there are two rules applicable here. First rule is quotient rule. Second rule is power rule. Okay. So from power rule, what you are supposed to do? You have to multiply this power and take this. Okay. So 1 by 2 into this value. Okay. So you can put here 1 by 2 into. So you have to divide this. Are you able to follow? So when you take this, that is 0 point once again, and 15 means 7, and then balance 4, 13, 6 2s are 12, balance 1, 13, 6 2 are 12, balance 9 2s are 18, that's all. So you have to check for 0.7669 antilog, not here, okay? So check the antilog. So the antilog is available on the next page. This is logarithm, and go through the next page. Antilog is available, and what is the value? 0.7669. So you have got 0.76 and check against 6 and mean difference 9. Okay, so how much? 5846. That's good. So you have to put 5.846 into 10 power, and whatever the value available here should be written as 10 power 0. That's all. You know already 10 power 0 is nothing but 1. So you can claim 5.846 as the final value of square root of 3.114 divided by 9. Now you have to include that 10 power 6 also. Is it not? You can erase this portion and include that.
So 10 power minus 1.
10 power?
Minus 1, so 1 bar 0.5 pt.
10 power minus 1. You can put 10 power minus 1. So 5.846 into 10 power 5 meter per second. I hope now you are able to calculate using logarithm also. Okay. Now let us work out how we were able to get the meter per second for velocity from the joule. So we have got already, what is that equation? V squared, write down. V squared is equal to, what is that? Can anyone tell me?
1.5 into 7 into 10 power minus 19 into 2.
Yes, sir. V is equal to, V squared is equal to 1.557 into 10 power minus 19. No, you can put simply, that is the kinetic energy value. You put simply KE value. V squared is equal to KE divided by M, mass, that's all, into 2, forget about 2, that is constant value. So KE by M, small m. Now take the unit joule divided by, put a vertical line, joule divided by mass, kg. Okay, what is joule? Energy, capacity to do your work. Is it not? So this is V squared. So V is equal to what? Square root of J by kg. Okay. Right. What is J? Put J. J is equal to what? Anyone? Work done. Work done means that is capacity to do a work, which is nothing but work. So work and energy have the same unit. So joule. So work done means what? Force into, tell me, force into displacement. Okay, so work done, W is equal to force into displacement. Right? Yes, you have to put yes. Yes means displacement. And what is force? MA, mass into acceleration. Write down. So W is equal to MA into S, right? So W is given as joule. So J is equal to kg. Mass is given in kg. Small k, small g. Into, what is A? ms power minus 2, is it not? ms power minus 2 into S, second. Okay, so it means kg meter per second square. So this is joule. Now we have to cancel this. So it becomes second power minus 1 kg ms power minus 1. Okay, and now this kg, take down ms power minus 1 divided by kg ms power minus 1. No, joule is equal to kg ms power minus 1 divided by kg.
Substitute.
V is equal to, we are working on velocity then. V is equal to, right up. What is that? Joule by kg. That's all. V is equal to, what is joule? Kg ms power minus 1, right up. Divided by kg. So the kg can be cancelled. Now you have got meter per second. Okay. Now it's clear that you have obtained the relation. In fact, you can verify your equation, whether your equation is correct or not, based on the unit. Okay, right. So let us declare the answer. What are the answers? Please read out.
Energy of photon in electron volt is equal to 3.10 electron volt, 102 electron volt.
Then
Kinetic energy of emission of photoelectron is equal to, in electron volt it is, the answer is 0.972 electron volt. In joules it is 1.557 into 10 power minus 19 joules.
good.
Velocity of photoelectron is equal to 5.84 into 10 power 5 meter per second.
Okay. And we have already given
Constant
this
value.
constant value. Okay. Right. Very good. Thank you.